Welcome back, my dear students, to the part 3 of today's session. In this module, let us discuss about reversible and irreversible processes. A thermodynamic process is reversible if the process can return back such that both the system and surroundings return to their original states with no other change anywhere else in the universe. It means that both the system and surroundings are returned to their original states at the end of a reversible process. A process can be reversible only if it satisfies two conditions. Dissipative forces must be absent and the process should occur in infinitely small interval of time. In simple words, the process which can reverse back is completely a reversible process. This means that the final properties of the system can perfectly reverse back to the original properties. The process can be perfectly reversible only if the changes in the process are infinitesimally small. In practical situations, it is not possible to trace these small changes in an extremely small time. Hence, reversible process is an ideal process. The changes that occur during the reversible process are in equilibrium with each other. Examples of reversible processes are extension of springs, slow adiabatic compression or expansion of gases, electrolysis with no resistance in the electrolyte, frictionless motion of solids, slow isothermal compression or expansion of gases. Now let us see what is meant by an irreversible process. Irreversible processes are a result of straying away from the curve, therefore decreasing the amount of overall work done. An irreversible process is a thermodynamic process that departs from equilibrium. That means which is not reversible. In terms of pressure and volume, it occurs that when the pressure of a system changes, then the volume do not have the time to reach equilibrium. A classic example of irreversible process is allowing a certain volume of gas to release into the vacuum. By releasing pressure and allowing it to occupy a large space, the system and surroundings are not in equilibrium during the expansion process. Hence, a work is to be done here. However, there is requirement of significant work with a corresponding amount of energy dissipation as heat flows to the environment. This is in order to reverse the process. In short, irreversible process cannot be brought back to its original state. A few examples of irreversible process are relative motion with friction, throttling, heat transfer, diffusion, and electricity flow through a resistance. Hope you have got an idea about reversible and irreversible processes. In short, in a reversible process, all states of the system and surroundings are in equilibrium. Whereas, in an irreversible process, equilibrium is not maintained during the process. Thank you, dear students.